1 out of 4, that's the same as taking 4 over 16, isn't it? And that's the same as 2 over 8. Are those all equal to each other?
Yes.
They all equal what decimal? 0.25, which is what percentage? Which is 25%. So that's a good way to think about it. A proportion compares two numbers. Okay? We write it in fraction form a lot of the time. Similar triangles. That's the next piece of information that you need to know. Does anybody remember what a similar triangle is? Or how to know if something is a similar triangle?
You gotta have right angle.
Okay, something about them does have to be the same. Yes. The corresponding sides are proportional. Now, because they're proportional does not mean that they're the same size, okay? It just means that they have the same rate, pretty much. So think about this. If I give you a triangle that is, let's say this is 10 and 12. The side length is 10 and 12.
Yeah, that means the other side is gonna be 10 years.
Yeah, likely it will be. Okay, so 10 is to 12 as 5 is to 6. Is that true?
Yes.
How do you know? Yeah, if you take 10 divided by 2, it's 5, and 12 divided by 2, it's 6. So you can reduce it by 2. Okay, that's a very good way to think about it. Also, 10 over 12 is equal to 5 over 6. What's that decimal?
10 over 12, probably.
They're both the same. What do they both equal?
Repeating. It's repeating.
8.8. What is it? Is it 0.8 or 0.38?
So 0.8 with a
0.83.
Yeah, like
is just the 3 repeating?
Yes. Yes. It's not
Okay. So her explanation of taking 10 over 12, and they're both, if you take both of them and divide by 2, it will be 5 over 6. That is a very good way to think about it. Also, what can you do to 5 to get 10? Multiply it by what?
2.
What can you do to 6 to get 12? Multiply by 2. Okay, so that's a good way to see. They both are changing by the same amount of units. So that's what makes these similar triangles. It makes them proportional. All right, corresponding sides are proportional. What does that mean? What does corresponding sides mean? Okay, what side corresponds to the side that has a length of 10? Yeah, 5, the side length of 5 corresponds to the side length of 10. They're both in the same position, right? Okay. One is just bigger than the other, but they're both in the same position, and we know that these are similar triangles because we checked it. All right. So let's look at something else. What type of triangle is this?
Corresponding. Oh.
Okay, this is a right triangle.
The line going like this.
How do I know that this is a right triangle?
It's 90-degree angle.
Has that 90-degree angle. This is a 90-degree angle. That makes it a right triangle. That's how we know. All right, does anybody know what this is called? It is definitely a line, but it has a very specific name for a right triangle. It is a diagonal line, but it has a specific name. Does anybody know it? That's very good. Hypotenuse.
Oh, I remember that.
It's the hypotenuse. Where's the hypotenuse located? How would you describe somebody about the hypotenuse? You can't say it goes like that, though, because what if I turn my page like this?
Horizontal. Is it horizontal?
They're all horizontal depending on how I turn my page, right? Okay, so we'll call it the horizontal line, but that's not how you would describe to somebody where it's located on a right triangle.
Can you see the
Located on the edges.
Okay. The hypotenuse is located across from the 90-degree angle. It does not touch it, it's across from it. That's how you know which one is the hypotenuse. Okay? It's across from the right angle.
Right angle. So that's how we tell somebody.
Yes. There is also another special characteristic of the hypotenuse. You'll need to know this later. You won't use it so much right now, but just so that you do know, it is the longest side. It's okay. Moving on. So knowing that about a right triangle, now we have the correct terminology to talk about it. Oh wait, one more thing I forgot. Does anybody know what the terms are for these side lengths? Just the sides themselves.
You said the name?
Yeah.
Left and right.
They're both called a leg. The legs are touching what? The 90-degree angle. Yeah.
So they gonna be like a stretch.
No, it's touching the right angle.
The legs form that right angle.
Hey,
And and the hypotenuse is across from the right angle. So everything kind of centers around knowing where that right angle is.
so the right angle is the symbol.
Yes, the right angle is what tells us what everything else is. All right. Sketch a small graph.
You might well use the blue line on already.
Okay, so we're looking at this graph of a line. What type of slope does this have?
Positive.
We definitely know it has a positive slope because it's increasing from left to right, correct?
Yes.
All right. Now, I'm going to label some slope triangles on here. I'm going to start with this intercept, the y-intercept here. We don't know what the number is. We don't have any numbers, but that's okay. We don't have to know any numbers to talk about the relationships that we're about to talk about. Okay, so let's see. We go up and then over. What type of triangle does that form? It forms a right triangle. And the slope of this line is also the hypotenuse. Okay?
Oh, we can make a couple hypotenuse. You see the one in the middle?
Yes, we can.
Bet.
All right. And let's make another slope triangle.
Go all the way up. 1, 2. Go over 1.
Okay.
Yeah, go over 1.
You want me to go over this way?
Yeah, go over that way. Hypotenuse.
And so there's another hypotenuse there. What can you say about the slopes of the hypotenuse on both of these?
They all the same. They the same size.
They're all the same. So the slope of both hypotenuses are the same because they're on the same line. So they're equal. All right, now